Okay, let's continue look at class relationships. This time we are going to look at special kind of associations called aggregation and compositions. So let's begin with aggregation relationships between two classes. So aggregation represent ownership between two objects of two classes. Okay, let's look at one example. I will draw very simplified class diagram again. I'm going to use only class name. So here is one class diagram. We have a student class. And then we have another class. I will call it as an address. So student has address. So let's look at the multiplicity. So address may have at least 1 to 3 students. Then student has at least one address. So if you look at here, relation between student and address, that actually we code it as aggregations. It looks like a diamond shape. They represent ownership between the student class and then address class. So it means that object of student's class own object of address class, or we can say that student object has access to address object. Let's look at the compositions. Also, composition is also part of the associations. They represent whole and part relationships. Between normally two classes. So let me draw very simple again, similar to address. This time I will say name. So again, student has name, okay? should have at least one official name. There is only one. Again, a bit unusual, but we say that name belongs to one student. So here again, same diamond shape, but this time it's filled in. Again, it's the same diamond shape, okay? Okay, post aggregation and composition, we were looking at binary relationships. So we are going to look at another relationship of aggregations. So let's say if we have one class, we can have a relationship within this class. So let's say aggregation here. So we have a person who is a supervisor of employees. It means that we have one supervisor. Let me copy paste it. Some cases, person may have more than one supervisor. Okay, so let me just explain here. A person may have a supervisor. Here we say that a person may have several supervisors. So let me fix that one. Should be many. So let me move a bit down here. So explain. So if you're looking at aggregation here, students. So each student has only one address. And on each address can be shared by up to 3 students. So you may looking at university dormitory, the unit shared by 3 students. In that case, there might be 3 students' name on it, or 3 students belongs to that particular unit. Here, each student has one name, and then name is unique for each student. For simplicity, we just say name is unique for each student. Okay. Add some minor notes. Here, aggregations, it looks like a diamond shape. compositions you have to fill in. Again, looks like a diamond shape. You have to color in. Let me use a brush. It doesn't help, but you know what I mean. Okay, so that's the compositions, and in terms of association relationship between two classes. Okay, let's look at implementation, part of aggregation and compositions. So I just create a new project. This is going to be my application. Okay, here. Let's begin with aggregations. So if you look at here, students has address. So let's say student class, which is aggregating class. We have our address. So address, let me begin with only one property. I will say city, and then I'll just say my city. Just default value. Let's create getters and setters, and then two string methods, so that we can see what's inside the object of address class. Okay. So we go back to student class. Now we see how address can be aggregated to student class, or how they actually implement aggregation relationship between student and address. So we use address class as a property here. So private address and address. Okay, that's it. So we call as a student as an aggregating class. Address call as a aggregate class. Then we are going to do the same thing. Okay, to process the students objects here. If you have a student object, here you need to find a way to process properties belongs to student object. Okay, so we come back here, then say getters and setters. Okay, for address we also need one toString method, so we can see what's inside the object. Okay, so we have one getter and setter for the address class or address object. I will save and then go back to Java application 47. Sorry, somehow I forgot to save it, so let me just type it again. Students, students, new students. Okay, here we say set address, so we need to deal with the address object, which we don't have one, so we create one using default constructor. Then address class has its own setters and getters. So let's say enter city. So I'm going to use scanner class to process standard input device. Okay, keyboard input basically. Import scanner class. Again, string city. Next, we'll process string value. Set city and city. Okay, so we have one input. Then here, let's see student.toString will return string value, so let's print it out. Clean and build. So I will type New York. So it overwrite the value New York. It was my city. Okay, default value was my city. So that was aggregation. Let's look at compositions. So we need a name class. I will say very typical ones: first name, middle name, and then last name. For testing, I will have a default value for first name and then last name. Again, we are going to have setters and getters, 3 pair of them, and then toString. Okay. So we have a private name. Again, the same thing, aggregate class. Then here I will add setters and getters. Again, in order. So we have address, then we deal with the name, toString methods. This time include both of them. So we have a name and address, okay? Again, I'm going to do the same thing again. So here I will say name. Sorry, forgot new. So input process, okay, we have one more input. I will do only first name, okay. set first name, then I need to save to name object. And then save to student, okay. Student set name, okay. That will print, okay, that will print address and then name, okay. So I will type something else, Johnny, instead of John. So we have New York and Johnny. Last name is still same, Doe, okay. Default value was John Doe for student name. Okay, let's look at the diagram. Pretty much the same, okay. So student has aggregation and compositions. So let's look at the aggregation with another relationship. So we are looking at the person. Again, it's straightforward, okay. So this one besides the aggregation between same class. So we have a private person and the supervisor, okay. Second one is also same. Let's say this time we have a multiple supervisor, so you just need to consider as an array. So let me comment it out, type it again. Person, here you may have multiple supervisors, okay. That's it. Actual implementation, I will just leave it to you. It's pretty much same as the previous one, okay. So let's look at the inner class. So when you're looking at student class, we can pretty much guess that students class has two classes associated with students. So we have one student class called address, and then the other one is a name. Those two classes can be used only for students. Then we can embed it within the same class definition here. So what we say it as classes. If name or address or both is used in the student class only, then we don't have to separate definitions, or we can implement it together. Well, we call it as classes. So let me show you how. So you go back to address, copy, class definitions. So here address class means this address class belongs to student class. So here we say the class is public, and when we have a class, we have to make it less visible. So less visible for public happen to be default. So you can just remove it. Save. The second complaint says that you already have address class. So we remove it. Okay. So we don't have a separate address class. we just have a student class and then with the one inner class called address. Let's see how it works, or whether it still works or not. Okay. Again, New York, Johnny. It actually works. Include address called New York. So now we can do the same thing, okay? So address works as an inner class. So we make a name as an inner class as well. Okay, that's visible, so I will not copy public modifier. Just make it as a default. And then complaint is it already exists. So let me just remove name class. Okay, remove. So we have a single source file with one student class and then two inner classes in it. Let's clean and build. Same thing, Johnny. So we have student class down there. Okay, if you look at navigator window, address. Okay, inner class address. We have a name. Again, name inner class. But we have only one source file. Okay, that's how we can use multiple classes in a single class. If you click files and then field and classes, once you compile it, it looks like we have a separate classes too. So that's how we use inner classes. Again, let me quickly have a look. Here we have a student class and has aggregations. Relationship is aggregation between students and then address. And then we have a student as a student also has compositions with the name class. So if you look at here, line number 20, 21, 22, actually 21, 22, 22, let's say aggregations. Then line 21, that is composition relationship between student and then, sorry, line 23, okay, student and name class, okay, compositions. In terms of implementation, there's not much difference between aggregation and compositions. In terms of association relationships, you may need to know what's the difference between aggregation and compositions. By actual implementation, they are pretty much the same. Okay, now as long as you use them as properties, then you can implement it the same way. Okay, they are same. That's all. Thank you.